Yeah, good day, class. My name is Ayo, and why today I'll be taking you guys physics today. Why in our previous class and our next class, I'll take you guys mathematics. Now today is talking about elasticity. What do we call elasticity? This can be defined as the ability of a material to regain its original position, shape, after it has been distorted by an external force. Now, in this elasticity, now what's that we call Hooke's law? We call Hooke's law. Now, this law it guides materials under what? Under elasticity. Now, why the law it states what? It states that provided that the elastic limit by elastic material is not exceeded, the extension of the material is directly proportional to the applied force or the load. Now, gravity force is directly proportional to the extensions. Simply means that the force equals the stiffness and the extensions. Now this is what they call the force. The F is called the force. The after is the force. While the K is called the stiffness. After the stiffness, we have the E, call it the extension. Call it the extension. Now we have terms in Hooke's law. Now these are the terms under Hooke's law. We have the stress. We're talking about the stress. We have the strain, and we have the elastic limit. We have the elastic limit. We also have the Young modulus. We have the Young modulus. Now, what do we call about what is the stress? What is the meaning of stress? What is the meaning of strain? What is the meaning of elastic limit? And what is Young modulus? Talking about the strains, the stress. Now, stress simply defined as what? As the ratios of the force. Stress called the ratio of the force by the cross-sectional area. So it means that the definition is what? That already simplify what or implies the formula of what? Of the stress. Now the first is we have the force as what? As the unit of Newton. What have what area as what? As meter square. Now this is how to get its unit. So be able to have it as Newton meter per square. That gets a unit of what? Unit of the stress. Now the stress can also what? It can also be the force over formula of area is what? Is pi r what? Squared. That is what we call stress. Now let's think about this strain. Now what is strain? Talking about strain. Strain also what? It's also the ratio of the extension over what? Over the length. You have the strain, you have the strain. Strain is what? Ratio of extension over the length. Now strain doesn't have any unit because the extension has what units of what meter, and also length also is what a meter. You can't see anything out. I want to have the strain unit as what? As nothing. So it means that the strain doesn't have any unit. Now then we want to elastic limits. What do we call elastic limits? It can be defined as the point in which an elastic material gets to, and it doesn't be able to get back to its original shape after the stretching force. Now let's take a note of this. Now we have a spring on this. Now we have a spring here. This is a spring. And why the spring has a force? That tells me that the spring has a force of 1000 Newton as a spring. Now when you drop a spring on this, like a force on this spring now, it's going to make the spring to extend beyond its elasticities. That is beyond its elasticities. And when it's getting beyond the elasticity, it simply means that the elastic material will not get back to its original shape again, because it is beyond the elasticity. Now that is on elastic limit. Now what about Young modulus? Talking about Young modulus. Young modulus is also the ratios of the stress and the strain, which is we are going to use E to represent the Young modulus, which is the ratio of the stress with the ratio of the strain. Now the stress has the formula of now the force over the area. The strain is extension over the length. So we're going to have the Young modulus equals to the force over area. This is division sign. Then extension over the length. Now to change this division to times, we're going to interchange right hand side. which is the young modulus equals the force over the area times the length over the extension. So we're going to have our young modulus. So we're going to have young modulus, which is equals to the force over, that is, this times give us the force times the length over, we're going to have what? Yes, the area and the extension. This can also be called cross-sectional area. So it means to find the force now, we are going to make that the subject of the formula, which is by cross-multiplying. So we're going to have the force times the length equals the young modulus, the extension, and what? And the area. Divided by the length, cancel out this, that the force equals young modulus, area, extension, and what? Over the length. That's what? That's the last formula. Now, guys, don't forget to what? To like and what? And share. So next class, we are going to talk about calculation aspect. Coming very soon.